Now this question says, in the diagram all measurements are in centimeters. The lengths of the sides of a triangle are 2x plus 9, 2x minus 3, and 4x plus 5. Find an expression in terms of x for the perimeter of a triangle. Give your expression in its simplest form. Now this takes us to a topic I titled perimeter and area of a triangle. This is merely perimeter, okay? But we're still going to talk about area, okay? Now for perimeter of a triangle, a triangle is a shape that has three sides, okay? It has three sides. Now we're told for this one that this is 2x plus 9, 4x plus 5, and 2x minus 3. The perimeter is simply the distance around the triangle. So you're supposed to add this plus this plus this to get perimeter of the triangle. So we have that the perimeter equal to 2x plus 9 plus 2x minus 3 plus 4x plus 5. Okay, now let's gather like terms. Let's put all the x together. We have 2x here. Anyone will take it 2x. Then we have 2x plus 2x again. So you have plus 2x. Now you have plus 4x here. Plus 4x. Okay, now you have 9 here. Plus 9. You have minus 3 here. So minus 3. You have plus 5 here. Plus 5. Okay, now this is going to give us 4 plus 2 is 6. 6 plus 2 is 8. So you have 8x. 5 minus 3 is 2. 2 plus 9 is 11. So plus 11. Okay, so this is how we calculate the perimeter of a triangle. Okay, now the second question said that the perimeter of the triangle is 39 centimeters. Find the value of x. This is just to ask us to equate this we have to 39 centimeters. So since we are told that the perimeter is 39 centimeters, we have 8x plus 11 equal to 39. So 8x will be 39 minus 11, and that will be 9 minus 1 is 8, 3 minus 1 is 2. Okay, so 8x will be 28. Then your x will have to be 28 divided by 8. 4 divided by this is 2, 4 divided by this is 7, so your x will be 3.5. okay, 3.5 centimeters. Now this is still a way after calculating perimeter they could add any other thing. Now this is a very easy way of calculating perimeter. This is a very easy perimeter question. Now let's go ahead and find more questions on perimeter. Now this is another question on perimeter, but it took another form. Now we're told that here is a triangle ABC. Okay, now we're told that AC is 90 meters. AC is 90 meters, that's here. Now BC is 60 meters, and angle ACB is 130 degrees. Calculate the perimeter of the triangle. Give your answer correct to one decimal place. Now the first one, we're just given a triangle and just told to add all the sides and just give the answer as a perimeter. But this one, we're given two sides and one angle, and we're asked to find this side first before we now calculate everything and find the perimeter. The perimeter is distance round, that's this plus this plus this. Okay, now if you're given this kind of thing, just ask yourself, what angle is this? It's not 90 degrees. If it was 90 degrees, we would have used Pythagoras theorem to get this. By then we would have called this a hypotenuse. Okay, but it's not 90 degrees. So the best formula, and we're given two sides and one angle. Okay, so the best formula to calculate it, even if I wanted to use sine formula and say sine, sine formula has this format: sine theta over side A. Okay, or sine A over side A, or rather A over sine A equal to B over sine B. You could have it like this. Okay, but you normally use it when you have two angles, okay, and maybe a side you want to find another side. But this time around, when you have two sides and we'll have one angle, so we're going to use a unique formula called the cos rule. Okay, that's the cosine rule, and this rule says that this squared, it's more like more like Pythagoras theorem in a bit, but it takes another format now. Cosine rule, we have that this squared plus this squared, okay, then plus 2 times this, then cos this angle will give us this. Now let's write that down. Okay, we have that a squared, or 60 squared, plus 90 squared, plus 2 times 60 times 90, okay, then cos this angle in between them, 130 degrees. Now when you calculate this, now you'll be able to have this AB, okay, that's this squared. Now when you have two sides and an angle in between them, okay, and you have to find the other side, you just know that it's cosine rule immediately. Okay, now to be able to do this, we calculate 60 squared, close your bracket, plus 90 squared, okay, then plus 2 times 60 times 90, then cos 130. That will give us about 4,000. Okay, that is supposed to give us square of this, please. It's supposed to give us square of this. You know the way Pythagoras is hype squared equal to base squared, or adjacent squared plus opposite squared. Okay, now this is also the same format in a bit. This adjacent, these two now that has the angle in between them, that's the ones that they are the ones that will have squared, then plus 2 times the two of them again, cos the angle in between them, equal to this squared. Please don't make that mistake and say it's AB, this squared. Okay, now we have this. Now calculating the square root, you have that the square root should be equal to 68.977. now we're told to correct to one decimal place, so it's going to be 60. Corrected to one decimal place, this one is more than 5, so we add 1, so it's going to be 69 meters. Okay, now the perimeter will now be, this one being 69 means that the perimeter is this plus this plus this, so we have that 69 plus 90 plus 60 is going to give us 219 meters. So that's the perimeter. Now you see the long way we've gone, because we're not given this side and we're asked to find the side first before we now calculate the perimeter. Okay, and we from here now we said, okay, since this is not a right angle triangle, to find this side we have to use cos rule, and that cos rule means this squared plus this squared, okay, then plus 2 times of this and this, then cos the angle in between them. That will give you the square of this. So to find this, you have to find the square root of that answer you got. That means that's what gave us this. Okay, so that's it for perimeter questions. Perimeter, they're normally easy, except if they add a little twist to it, like this question. Now we'll go ahead to area questions. Now looking at area questions, how do we find area of a triangle? Now you know there are 3 types of triangles basically. You have the right angle triangle, okay, that has one of its angles to be 90 degrees. Then you have an equilateral triangle that has all the sides equal and all the angles equal. That's 60 degrees, 60 degrees, 60 degrees. How do we know that they are 60 degrees each of them? Because angles of a triangle sum up to 180 degrees. So since we are saying that all the angles are equal and there are 3 angles, so we just know that it's 180 divided by 3. That's 60, 60, 60. Now after this we have isosceles triangle. Isosceles triangle, 2 sides are equal and the 2 angles are equal too. Okay, now when we're talking about this right angle triangle, okay, in case we are given a question to find the area, okay, Now the area of a normal right angle triangle is half base times height. Okay, we just multiply half by the base times this height. For example, in this question now we're told that ABC is a right angle triangle. AC is 6, that's the height, and BC is 14. And then we're told to find the area. The area is just half times the base is 14 times the height 6 over 1. Cancelling out, you have 7. 7 times 6 is 42. So the area is 42 centimeters squared. Now this is as easy as the easiest area question you can get, and that's from a right angle triangle. Okay, now when you have area questions in all these other types of triangles, it takes other formats. Now let's get to see those other formats. Now for example, this question now that says in triangle ABC, AC is 5 centimeters, BC is 8 centimeters, and angle ACB is 75 degrees. Calculate the area of the triangle ABC. Now let's see a sketch of this. Now we're told that this is 75 degrees, and this is 5 centimeters, and this is 8 centimeters. This is AB. Okay, now we're told to calculate the area of this triangle. Now trying to calculate the area of this triangle, now we can see that if you come and do half base times height, it won't even make sense, because where would you call the height? Okay, and you won't even call this the hypotenuse, because it's not a right angle triangle. They've already given you this side as 75 degrees. They didn't give you this side as 90 degrees, so you can't just go ahead and do half base times height. So how do you solve this kind of question? Now remember that normally for a right angle triangle, the area is half base times height. Okay, now for this triangle, now instead of saying half this times this, we'll do half this times this, and then we'll now do sine of this angle. Okay, we normally say area equal to half, we normally call this A and call this B, half AB sine theta. So in case you're given any question on area, okay, area of a triangle, and you're given two sides and one angle, just go ahead and use this formula, because that's the basic formula you use for all the area of a triangle questions that have two sides and one angle. So to find the area of this triangle, we're going to do half A is 5 times B is 8 times sine 75. Now let's punch this out on our calculator. We have 5 times 8 divided by 2 times sine 75. We'll have our answer to be 19.318516. Okay, then we're told to correct to three significant figures. You have 1, 2, 3. That is 19.3 centimeters squared. It's actually in centimeters. Okay, now this is the way you calculate area of a triangle with two sides and an angle. Now let's see another scenario. Now this is another scenario that we're asked. We're told that ABC is a triangle and AB is 8.7 centimeters. Angle ABC is 49 degrees and angle ACB is 64 degrees. Calculate the area of the triangle. Now you see, the other question was given two sides and an angle. Now we're given two angles and one side. How do we calculate this? Now to be able to do this, we have to find one of the sides. Okay, now if we're able to find one of the sides, we'll now use that former sine rule that we used earlier and solve it. Now to be able to do this, we can use sine rule. Now when they give you two angles and one side, it's normally sine rule that you use, and sine rule is only sine rule that you use to get one other side. Okay, so if you look closely, you can see that sine rule will make use of angles and the sides opposite them. Now this is an angle, this is a side opposite it. This is an angle again, the side opposite it is here x. Okay, now we can use sine rule and find this. Okay, then we'll also find this angle, so that we'll now use these two sides and this one angle to calculate the area of this. Now, so how do we do it? Let's go ahead. For sine rule, we have A over sine A equal to B over sine B. What do we mean by that? Now the A will be the side opposite the angle. The sine A will be sine of the angle opposite the side. Okay, equal to B. B will be the side opposite the angle. Then sine B will be sine of this angle that is opposite this side. So now let's do it that way. X over sine 49 equal to B is 8.7 over sine 64. 8.7 over sine 64 degrees. Okay, now solving this further, we're going to try and cross multiply. This multiplies this and this multiplies this, so we'll have x sine 64 equal to 8.7 sine 49. Okay, so your x, dividing both sides by sine 64, you have 8.7 sine 49 divided by sine 64. Now let's punch this out. You have 8.7 sine 49 divided by sine 64. We're going to have our x to be 7.3. okay, now that's our x now, and that's here. Okay, 7.3. Now, having gotten this, we've not finished. Okay, now we need to find this angle here. What is this angle here? Now, how do we find it? The sum of angles in a triangle equals 180 at all times. Okay, that's the basic rule. All the angles in a triangle must add up to 180 degrees. Now, to find this, we're going to do 180 minus this plus this. That's, we're going to add this 2 first of all. Then we'll now subtract all the sum from 180. So doing that, we have 180 minus bracket 64 plus 49, and it's going to give us 67 degrees. So now what we're now going to do is, for the area, we'll now do half AB sine theta, which is going to be half times 8.7 times 7.3 sine 67 degrees. Okay, 8.7 times 7.3 sine 67. Now it's going to give us area of 29.23 centimeters squared. Now basically we did the same thing we did the previous time, but first of all we have to find this angle and we have to find this side, so we could use this formula and calculate the area of this triangle. Now this is the more complex form of the first one we did, but this is how you normally find the area of a triangle that is not a right angle triangle. Now another type of area question is this. Now they said the diagram shows an equilateral triangle ABC with sides of length 6 centimeters. P is a midpoint of AB. Q is a midpoint of AC. That's P is a midpoint of this, and Q is a midpoint of this. Okay, now we're asked to find the area of this shaded region. Okay, now finding the area of this shaded region, we'll have to find the area of the triangle first, and now find the area of this sector. Okay, then we'll now subtract the area of this triangle from the area of this sector. Now first of all, for an equilateral triangle, okay, let's work with this point. We're told that this is a midpoint of this. Okay, now if this is a midpoint, that means from here to here is 3, and from here to here is 3. Okay, and it's an equilateral triangle, so all the angles are equal. That means this is 60 degrees. Remember, all the angles in a triangle add up to 180 degrees. So since all the angles are equal, you just divide 180 by 3, and you have for each of them. Okay, now this is 60 and this is 3. This is 3. Okay, now this represents the R of the sector. This represents the R of the sector. Now area of a sector, first of all, area of a sector will give you theta over 360 times pi r squared. Your theta here is 60. 60 divided by 360 times pi times your r is 3 squared. Okay, now have 60 divided by 360, okay, times pi times 9 is going to give you 4.712 as 4.712 centimeters squared as the area of the sector. Okay, now we need to find the area of the equilateral triangle. Now to do that, we can use half base times height here, but on one condition. We have to find the height. We have to find this vertical height. The height always has to be the vertical height. Now if we erect an invisible line here and call this our h, okay, now to find this h, this invisible line is dividing this triangle into two equal halves. So this is 3 and this is 3. Okay, so we now know the base and we know the hypotenuse. So we're going to use Pythagoras theorem. That says that the hypotenuse squared is equal to base squared plus height squared. Okay, we'll use that and find the height. Now to find the height, we're given that the hypotenuse was 6. Okay, so we'll have 6 squared equal to the base squared is 3 squared. The base squared is 3 squared. This one is 6, okay, plus h squared. We have that 36 equal to 9 plus h squared. So your h squared will be 36. This goes over, it becomes minus 9. Okay, so your h will now be square root of this minus this is 27. So square root of that should give us 5.196. okay, so that means the area of the shaded region will be 5.196 minus 4.712. And to give us, okay, let's do that again. 5.196 minus 4.712 is going to give us 0.484 centimeters squared. So that's the area of this shaded portion. Now that's all for perimeter and area of triangles. Okay, now the basic thing is look at what the parameters you're given. Now that determines what you're going to use, whether you're going to use half AB sine theta. Half base times height is always used when it's a right angle triangle. Then when it's not a right angle triangle, you use another means. Remember, for this one we have to make it a right angle triangle by erecting an invisible height. Okay, now that's it for areas and perimeters of triangles.